Hey everybody, Mr. Rubo here, and today we're going to do some factoring, just a review of it. So the first thing is there's really like three types of factoring that we're really going to look at right away. So the first type is GCF factoring. So GCF factoring is when you look at all the terms, doesn't matter how many terms there could be 2, there could be 100. You want to look to see if they have anything in common, meaning their greatest common factor. So in this example, we look at the numbers, they all have a factor of 2. Then we look at the variables, and they all have a factor of x. So we can factor out a 2x. And so we put that out in front, and then what we do with this term is we divide it by 2x. So 2 divided by 2 is 1, we don't need to write it. X squared divided by x is x. Okay, we do the same thing here. 4 divided by 2 is 2, x divided by x is 1, so it'd be 2 times 1, so we don't need to write it. So there we go. We have factored GCF. Okay, GCF factoring you always want to check for first, because if you could factor something out easily like this, you might then be able to factor what's left over in a different method. Okay, and if you don't factor out the GCF and you just factor out a common factor, you might have to factor out again. Like if you only factored out 2, you'd still have x squared and x here, which means then you could have factored out the x. So try to always look for the greatest common factor first, but if you don't get it the first time, just always pay attention to what's left over and see if you can do it again. Okay. The second type, which is the one that you probably use most often in terms of out of the last two, GCF is probably the most common, but it's product sum. So there's lots of different ways of going about product sum. I'm going to show you my method that I use. If you do a different method, that's totally fine. But yeah, so for my method, first let's get an example here. So I'm going to say 6x squared minus 5x minus 4. Okay, so product sum works with trinomials, right? As long as the powers are in a ratio of 2 to 1 and then the constant, you could do product sum. Or you could try product sum, I should say. Remember, with factoring, sometimes stuff isn't factorable, so that can happen. All right, so I started with this one because it has this a value of something other than 1. And these are always the ones that give students trouble. So if you know how to do this one, you can do the same steps when a is 1. Okay? So for product sum, what you need to do is you take your a value and your c value and you multiply them together. So 6 times negative 4 is negative 24. And then you take this middle term, the one with the x, and that's going to be your sum. So as far as like organizing this goes, I do a little x, so I call this the x method. Probably has a fancier name, but whatever. I put the negative 24 up top, I put the negative 5 down here, and now I want to think of two numbers that multiply to give me negative 24, so their product is negative 24, and they add to negative 5, so their sum is negative 5. That's where the name comes in. So, going through all the numbers, you hopefully come up with 3 and negative 8, right? 3 plus negative 8 is negative 5. 3 times negative 8 is negative 24. All right, so now what we do with those two numbers is we take our trinomial, and the first term will not change yet. We then take the middle term and break it up into these two numbers. So the 3 is positive, so it's going to say plus 3, and we just attach the x because we're taking it from this term. Then we're going to do the same thing with the minus 8, put an x on it, and then the minus 4 stays the same for right now. All right. So now the next step is to group the first two and the last two, the first pair and the last pair. So once you do that, now it's actually going back to GCF factoring. So you look, oh, these two have a 3 in common and an x. So then you're left with 2x plus, and now this is something that happens a few times with GCF where you factored out the 3 and the x, so that means you are left with a 1. Okay. This side we would factor out. If this is negative, you almost always want to factor out the negative, whether or not this is negative. So if that first term in this group is negative, factor out a negative. So we look at the numbers. Oh, they both have a 4 in common. So I'm going to factor out a minus 4. We're left with 2x plus 1. Nice thing with this method is you know you've done it right, even before you get to your final answer, if these two things are the same. Okay? If you end up where one is the opposite of the other, so it'd be like if this one was negative 2x minus 1, that just means that you should have factored out a negative as well. Okay? But you should end up with being the exact same thing. So now you take what's similar, and you're actually technically factoring it out of both. It's another GCF factoring. So you take that, you factor them out, and then you're left with 3x minus 4, and there is our factored using this product sum method. You know, there is guess and check, and there is a few other methods, but this is definitely the one I find to be the most helpful, and it gives you like just steps. Like it's not guessing, right? All right, and then the last type of factoring is going to be, for right now at least, there's more, but I can't write today. Difference of squares. So this case is really just a special case of product sum when it happens. So the thing you have to look for is that your first term and your last term are perfect squares. Okay? So if it involves a variable, you'll see it being squared, or it'll be to the 4th power, or to the 6th power, any even power for variables. But for numbers, you're looking for like 1 should hopefully not be an issue. 1, 4, 9, 16, all those perfect squares numbers, okay? And then the other part of it is difference, which means subtraction. All right, so this right here is what you're looking for. And the way this factors, I could show, or you could apply the product sum method to it where your sum is 0. But easier way of doing it is just knowing the little shortcut that difference of squares, or we could say difference of 2 squares, I should actually say, because then you could say dots, is a plus b, and then it factors to a plus b, a minus b. Okay, so just to see an example with one that you would probably see more than just a squared minus b squared is something like x squared minus 25, and we can even make it a little difficult. Let's go with this, 16x squared minus 25y squared. So we have x squared, y squared, those are clearly squares. 16 is 4 squared, right? 25 is 5 squared. So really, even though there's multiple things in this term and multiple things in this term, we could write this as 4x all squared. Then we could write this as 5y squared. All right. So now you can see, oh, well, my a is 4x, my b is 5y, So now I can factor it really nice to 4x plus 5y, and then 4x minus 5y. All right, and there you go. So there's the three methods of solving that, of factoring, I should say. We'll get to solving, that we're going to use now in this class. All right, so thanks for watching, and have a good day.